Yes, good day, ladies and gentlemen. Welcome to my physics channel. Today we are looking at a very simple topic, but which forms the basis or the very basics that of knowledge that a student needs to have. We're talking about vector addition, right? So my problem today is this object here. This is represented by the object with a dot, and there are a number of forces acting on it. And most of us, I think, we are already familiar with adding the two vectors which are perpendicular to each other, right? But here we have a situation where one of the forces, I'm using the force is a vector for this example, is the 5 Newton force. If you can see that one, it is clearly having components in both the dimensions, both the vertical dimension and the horizontal dimension. Right? Is that clear? So what do we call them? Yes, this one is a horizontal component, which we are going to call we normally call it fx, right? But what is it? The magnitude is 5, so it would be there's a component here. Let me put it in dotted lines. This is 5 cos 30 degrees, if that angle is 30 degrees. Then there's another component of it because it's pulling to the right and up. So these two, I'm putting them in dotted lines because they replace that one eventually. Because if you add this one and this one, they give you that one. If you decompose the 5 Newton force, it will give you the components. So this is vertical component, it will be 5 30 degrees. Right. Let's leave that one for now. Let's just briefly talk about how we add vectors in general. Normally, we are familiar with adding vectors which are perpendicular to each other. Let me draw them. We say this is 10 newtons. Then this is 6 newtons. And the way we add vectors, we do tip to tail. You know that. So it's going to be vector tail there. And then, so that's the head. Now, we take this one, put it tip to tail. I think we talked about it in another video, right? That is 6 newtons. Then the resultant, or the sum of the two vectors, this is the sum, right? The sum of the two vectors is what we call the F subscript R. I think for the chemistry people, you normally use F subscript R. If you see that one, it means resultant force, or this vector there. I've put it in dotted lines, right? The one that starts from there. Or we can call it F, if you are doing a IEB or the South African syllabus, this is F res, you've seen this. We also call it F subscript net, which is F net. Right. So all these are variations of the same thing. And by definition, I think this is the sum. So if you are asked to define resultant force, define res net force, you just say it is the sum total of all the forces acting on an object. Good. So that's how you do it. So if this was vector A, for example, vector B, and then the resultant would be this one, vector C, vector A, vector C. I'm sure you can, the representations that we normally have is like A. It would be A plus B. Yeah, if you want to represent the vectors now, what you get is vector C. Right. But how do we get the resultant force, the C? Okay. We say, but we apply Pythagoras theorem, which is C squared is equal to A squared plus B squared. I decided to use the A, B, and C so that because you're already familiar with Pythagoras. So to get F res, let me write it at the top there. We are going to say F res, you see the hypotenuse there, F res is or F net is opposite the 90 degrees, so we square that is equals to your 10 squared plus your 6 squared. Get the sum there, then eventually get the square root. F raised, F subscript raised will be the square root of that. Don't forget that your answer would be in newtons, but that is only the magnitude. Don't forget, whenever you are dealing with vectors, provide the direction. So you would have to get that angle there, for instance. So the resultant makes an angle of theta with the 10 Newton force. So you can just represent your final answer with two answers. The answer that you get there, right? Maybe it's, let's say it's 7 Newtons. But how do you get that angle theta? Yes, how do you get that angle theta? To get that angle theta, you use the Pythagoras theorem. Sorry, trig ratios. The best one is the tan. Opposite is 6, adjacent is 10. So you can say theta is the angle whose tan is 6 over 10, which is 6 over 10. You get that ratio and then put it on a calculator and get the angle. Then you can say the final answer, 7 newtons at an angle theta, which is 5 south of the 10 Newton force. Okay. Or yes, relative to the 10 Newton force. Yes, then you've got it. Right. So that's this simple vector addition there. Now let's do the problem quickly. Right. We need two vectors, like I said, so that we can apply Pythagoras. So we take, for example, let's look at the vertical dimension. And then let's take down as positive. Check down is positive. That's the first step, right? And apply your theory that the net force is sum. So we are going to say let's add the forces. Yes. Net force, we want one net force only for those that remember this one is good. We are going to use the components. Yes. So taking the vertical dimension, we are going to have 6.5 going down, which is the weight of the object, plus the x, plus this only this component going that plus, which is practically the opposite down because the so up is negative, minus 5 sin 30 degrees. Right? So this is in the vertical dimension. Let me call it F in the y direction. Okay, so the answer will be 6.5 plus sin that is half, that is plus minus 3 minus, this is 2.5, half of 5 is 2.5, and that's going to give us 4 newtons. It gives 4 newtons, so our resultant is positive, so it's going down. You can write down there. So we know the 4 newtons is going like that. Then let's take to the right, let's take to the east. Take to the east is positive. So this one will be negative. So to the east we have 5 cos 30. So this will be resulting in the x direction. So it will be 5 cos 30. 5 cos 30, right? Plus that component there. Or plus the 3, which was already there. 5 cos 30 is the component. I was supposed to start with the 3, plus 3. Right? And then minus 5 square root of 3 over 2. I just made it like that because cos 30 is square root of 3 over 2. I want this cos 30 is also 5 times square root of 3 over 2. I did it deliberately so that I don't need to use a calculator. Because all we need is examples. Right? So let me put my answer right at the top there. This was 4. I know I leave that one there. Then because of space, I want to carry this one up there. this sum. So 5 cos 30, 5 squared plus 3 whole, so the answer is 3 newtons. So it's 3 newtons positive, it will be to the right, to the east. So that will be so now again, once again, we are back to the starting point. Now we're left with the only two which are perpendicular to each other. One is going down, one is going east. I'm sure maybe there's no need now to carry on. We can just quickly draw it. So it will be your final resultant will be 3 newtons there and 4 newtons there. We need to just straight away 4 newtons there. So the resultant will be 5 newtons. Because these are just the so that we 3, 4, 5 there. The resultant to get this one, you use the same Pythagoras theorem again, and you know how to do it. Then you must find the angle. Let's say it's theta, then the angle stand is, what would that be? The theta. So theta is cos upturn. You get that angle. The angle stand is 4/3. Okay. The angle stand is 4/3. Right. So that would give you the angle. Let's assume that that angle is 40 degrees. If it was 40 degrees, and then your final answer would be resultant force or net force equals 5 newtons at an angle of, let's say it was, if you find the upturn, the angle stand is 4/3, you would say, let's say that angle is 40 degrees. You say 40 degrees, acting at a direction of 40 degrees south of east. Or you can give it as a bearing. Bearing is measured from north, directly from north, and as a bearing from north, you would add that 40 plus 90, that would be 100 on a bearing. So you can say bearing on a bearing of 90, 130 degrees. Right. So it's measured from north anti-clockwise. No, sorry, not anti-clockwise, clockwise. So that is it. Vector addition. There was a question in the chemistry. That is very simple. Remember, it was just, we said you have a vector which is like this. And then let's call it A, B. And another one was going like this. We called it N. They said, in which direction? Because in the Cambridge paper, multiple choice questions. In which direction is the net? It was a multiple choice question. In which direction will be the resultant of these two vectors? So you have to add them. But with the question was to add B, this vector B, and vector A. When you add them, the question was to add B to the reverse of vector A. So instead of doing A plus B, you have to do A minus B. The reverse of the vector is the negative vector, the vector that just cancels that one. So you add this one and that one. That was the question. So all you had to do, tip the tail, the choices were like this. B, I remember B was like this. A was something like that. C was, D was, which one is the best answer when you add that. So, but you have to make it up. Don't just guess when it comes to multiple choice. Actually, sometimes multiple choice questions are more trickier than the longer questions. So all you need to do, tip to tail. So if this one is reversed, it will come, it won't go like this, it will come now. Yeah, let me remove that quickly so that we're done with it. And so you see, let me just make it the best answer was just showing this. You don't do it Pythagoras, this is the resultant. So the best answer was this one. Good. Yes, I think this has been long enough. See you again. Any questions, don't forget to email me on my email address. @gmail.com. Yeah.